Okay, so this video is going to be an introduction to some review of systems of linear equation solving, which we'll need for quiz 4 in our functions and modeling companion lab, and we'll use throughout module 4 of our functions and modeling main course. Okay, so we're going to do a couple of different methods in this. We're going to talk about the substitution method for solving linear equations and the elimination method for solving linear equations, and then we're going to look at some special case results that we can get that we need to be able to deal with as well. So this first problem, we're going to use the substitution method to solve it. This is not a method that I personally use very often unless I have it exactly a setup like this. And what jumps out at me first about this system is I've got this x over here by itself, right? That's really good if we want to use the substitution method because it's very easy to solve that equation for x. And that's what we're looking for. If I don't have this kind of a setup where it's very easy to solve for one of my variables, I'm not going to use the substitution method. I'm probably going to use something else. But this is a perfect setup for substitution. So how do we do it? Well, we're going to start by solving that equation for that variable. We want to get a variable on one side by itself. This one, very easy to get the x. So I'm going to choose that first. Just move this 2y to the other side. Get rid of these. These are not like, so we just kind of bring them both down. Okay. And so we've solved for x in that first equation. Okay, the next step, if we're going to use substitution to solve this, is we're going to take this expression right here, and we are going to substitute it in for the x in the second equation. Okay, so we'll do that. Place that expression in for that x, so negative 2y minus 4 is going in there. Make sure you do put it in parentheses. That will definitely matter. We'll have to distribute across those parentheses to get rid of it. Okay, and then we're going to solve this equation. You'll notice there's only one y left in this, only one variable y left in this equation. So we should be able to solve it. We'll take this negative 4, we'll distribute it across the parentheses there. So negative 4 times negative 2 is 8. Negative 4 times negative 4 is positive 16. Okay, then we got a couple of like terms here to combine. So 8y minus 2y is 6y. Continue to solve. We'll move the 16 over to the other side. Divide. We get y is equal to negative 1. Okay, now you're not done. You do have your y value, but that is only half of your answer. When we're solving these systems of equations, the most common thing that will happen is that we'll get one solution that is an ordered pair. We're going to get an x and a y value. So this is kind of the half of my solution. It's the y part of my solution. To get the x that goes with it, all we've got to do is we've got to substitute. We can substitute really into any of these equations. This one will work, this one will work. I always, when I'm using substitution, like to do the one that's solved for x because I don't have to do any algebra. I just plug it in, work it out, and I'm good to go. So that's what I'm going to do here. I'm going to plug into this x equals equation here. So if we do that, x equals minus 2, we now know what our y value is. So negative 1 can go in there. Negative 2 times negative 1 is 2. 2 minus 4 is negative 2. So x is equal to negative 2, and that is the x value in this equation. So we've got our ordered pair, and that's what we're most commonly going to get for these problems is a single solution that is an ordered pair, an x and a y value. Okay, so we're going to look at another system. This one we're going to solve with elimination. The elimination method is the method that I tend to use more often when I'm solving systems by hand because it's just universally useful. Like in this one, if I was to try to use substitution, there's no variable in here that's particularly easy to solve for, to get by itself on one side. Whoops, got a little typo there. Sorry about that. That should be an x. So in general, this is a more useful method when you don't have a perfect setup like in the last problem that we did. So the strategy here is we're going to try to rewrite these equations so that the coefficients for one of our variables is the same values but with the opposite sign. So in this case, I'm looking at the x's. I've got a 3 and a 2 for my coefficients for x here. I can turn those into 6 and -6 pretty easily, right? We just take this top equation here, we multiply it by 2, okay? And we take this bottom equation down here, we multiply it by -3. 2 times 3 is 6, -3 times 2 is -6. Opposite values. We've got the same value but with the opposite sign. That's what we're looking for here. And the reason why we want to do that is because when we add them together, we'll get a 0. We'll eliminate one of the terms from our system here. So I'm going to distribute the 2 across the parentheses first. We need to make sure we do it to both sides of the equation to keep it balanced. So 2 times 3x is 6x. 2 times -2 is -4. And 2 times 8 is 16. Okay, and then we'll distribute this -3 very similarly. -3 times 2x is -6x. -3 times 5 is -15y. Okay, -3 times 18 is -54. Okay, add these equations together. 6x and -6x is equal to 0. They're going to eliminate. That's the whole point, the whole reason why we chose to multiply by these values, so we could get those coefficients to be the same numbers but with the opposite sign so that they cancel when we add them together. But we do need to add the rest of the equations together as well. -4y, -15y, we're just adding straight up and down the columns. That gives me -19y. Okay, and then 16 plus -54 is -38. We divide by -19 on both sides. And we've got our y value. Okay, again, this is not the answer, right? Because we're expecting the most common thing that will happen. Not always. We'll see some examples of where it doesn't in a minute. But the most common thing that will happen is we'll get one solution, and it'll be an ordered pair. Okay, so there's our y value. We do still need to get the x that goes with it. And again, we can really plug this into any of these equations we have up above that have an x and a y in it. I'm just going to choose the first one because it's probably the simplest one to work with, but you can't pick wrong. You'll get the same answer from any of these equations we have on here that have the two variables in them. So I'm going to plug this 2 in for y. So that's -4 there. Or add 4 to both sides. So 3x is 12. Divide by 3. And we get x is 4. Okay, so this is another situation where we got one solution and it looks like an ordered pair. That will be the most common thing that happens when we're solving these systems of equations. Okay, so I mentioned that when we solve these systems of linear equations, the most common thing that will happen will be that we'll get one ordered pair solution to our equation, or to our system of equations, but that doesn't always happen. Let's look at this problem. We'll solve it to kind of see what's going to happen. This is one that you really have options as to how to solve. It's perfectly fine to solve with substitution since this y is pretty easy to isolate. I personally will always lean towards elimination, so that's what I'm going to do here, but there's absolutely nothing wrong with solving this one with substitution as well. But, you know, if we're going to use elimination, our goal is to make these coefficients the same with the opposite signs. My eyes are drawn to the y's here first. I've got this -2 down here, so if I can make this into a +2 up here on the y, we're in good shape. So that's what I'm going to do. I'm just going to multiply this whole top equation here by 2. 2 times 4x is, or 2 times 2x is 4x. 2 times y is +2y, and then 2 times 4 is 8. And then I don't even have to multiply the second one because I've already accomplished my goals. I got the same coefficients, but with the opposite sign. But look at what happens here. You know, 4x, -4x plus +4x is equal to 0. These cancel. -2y plus +2y, those cancel. Okay, so everything cancels on the left side. What that means is I've just got a 0 left over here. On the right, -8 plus +8 is also equal to 0. So all of my variables canceled. Okay, and I got a statement that says 0 equals 0. This is an example of a kind of a special case that we'll run into from time to time when we're solving these systems. This is not a situation where there's one ordered pair solution to this system, okay? So we need to kind of make a conclusion based on this. And the question you want to ask yourself is, this statement that I got at the end here, is it true or false? This one is definitely true. 0 is equal to 0, right? And so what that is telling us is that there is an infinite number of solutions to this equation. Oh, sorry, I'm in a little trouble. My stylus right here. But there's an infinite number of solutions here. That's better. Sometimes we say infinite solution set. A little later in this course, we'll talk about how to write some of those infinite solution sets, but I don't think we really expect you to know that going in, so we'll talk more about that later. But what you do need to know is if you get a statement like 0 equals 0, that's always true, then you have an infinite number of solutions. You can go through that same process, solve it, and you can get something like 0 equals 3 or something like that instead, okay? And that the same things will happen where all of our variables cancel. If that happens, then we're looking at a statement that's always false, okay? And if our statement's always false, then there is just no solution to the system. This happens more often than you would think in the real world, right? You just get a system that's set up, you try to solve it, there's just no solution to it, okay? In that case, you'll get a statement like this where you get something that's always false, okay? So those are kind of the special cases you want to watch out for, and hopefully that's enough to help you get through the quiz number 4. But please let me know if you have any other questions.